Okay, now we're going to look at a system of equations, but let's look at an easy one first, right? So we have this system, and we just add the two sides and see what we get. Okay, again, we could do quantity 3x minus 2y plus the quantity 2x plus 2y, and then do all the simplification. But we know that we'll have a negative 2y and a plus 2y, and we're going to get 0 out of that, right? So really we can just look at it like this. 3x and 2x is 5x. Negative 2y and 2y is 0. 1 and 4 is 5. Well, 5x plus 0 equals 5. Can you solve for x? Well, I'm going to be, you saw what the solution was, okay? And you know perfectly well. But I'm just going to write out the steps because people are screwing up algebra by not writing out steps, and that should have been gotten over a month ago, okay? But seeing a lot of bad algebra in the class yet, okay? And it's getting to the point where we can't have that anymore. So I'm going to write out steps. 1/5 times 5x is x. 1/5 times 5 is 1, so x is 1. Okay? And I even left out a couple steps with the fractions that I don't want people to leave out, so if they do, they're going to get into bad habits. Okay, well anyhow, x equals 1. Now how are we going to find out? What we want to do, of course, is we want to find a value of x and a value of y that satisfies both equations. Okay? Well, now that we know x equals 1, how are we going to find out what y is? Well, we're going to plug x equals 1 back into either of these equations. So I'm going to draw a little arrow up to here. It's easier to hit that one than it is to squeeze in between this one. That's the only reason. That shows the first equation. And what do I get?
1x.
No, you don't get 1x. X is 1. You're not going to have an x when you replace x by 1.
Yeah.
Right?
Would it just be 3?
3, yeah. And what else? We want the whole darn equation, right?
Yeah. So it would just be 3
Yeah.
minus 2.
Yeah, you're saying you get 3. I'll write it out. 3 times 1 minus 2y equals 1. Or just 3 minus 2y equals 1, right?
Okay, yeah. All right. My mind goes blank until I see it.
Yeah, well, and then you got to go home and practice.
Yeah.
Do the homework soon after class, right?
Yeah.
That's a key. If you wait 2 weeks and you've forgotten everything that you knew, well, of course, that's another reason you want to take notes. So I'm going to give you a minute to take yourself a note on this, just so you are sure you understand the process. And remember, you're going to have the picture there, so you don't have to take a notes. It's not copying down the board. Okay? Not especially since I'll be posting this anyway. Okay? Taking notes is writing down what you need in order to understand this. What you need to see, what you think you'll need to see 3 weeks from now if you've forgotten this, to remind yourself of something you know darn well how to do, right? Okay? So anyhow, don't do that just yet, but I'm going to give you a minute to do it. Well, actually, if you got something you want to write down, go ahead.
I can write it down in a minute.
You know what you're going to write down?
Yeah.
Okay. Okay, so we got 3 minus 2y equals 1. You fill in the blanks. You get y equals 1. Right? Then you check. And we check in the second equation. Why the second equation? Because we used the first equation to get this. Now we haven't used the second equation since the very first thing we did. So we're pretty sure that if these work in the second equation, we didn't mess up. They're very high probability that if the result of this process works in the second equation, that we were right. Now we could also go back and check in the first equation, okay? After checking the second. You could check both to be really safe. But if something we get out of the first equation like this works in the second equation, we're pretty sure. Okay? So we're checking the second equation, which is what? 2 times 1 plus 2 times 1 equals 4, right? Because we plug x equals 1, y equals 1 in here, that's what we get. And that gives us 4 equals 4, it checks. So we're pretty sure we have the correct solution. Okay? Now, does that make sense?
Yeah.
Okay. Now, what do you think the difference between here and here is? What are you going to have to do here that we didn't do here? Well, if we add the equations, do we eliminate a variable? See, we eliminated a variable. We eliminated y.
Oh no, you'll have the extra variable because it won't equal out to 0.
I'm sorry, again?
It won't equal out to 0. Like it won't equal.
Yeah,
out
you're
to
not
0.
gonna eliminate. You're not gonna get a 0 for one of the variables, right? And you're got to get a 0 out of one of the variables, whatever. Okay, so what do you think you might be able to do to these equations that wouldn't change their solutions, that would allow you to eliminate a variable? And you are allowed to sit someplace besides behind the camera, but
Oh yeah.
yeah.
Could you add anything?
Again?
Could you add anything?
Well, whether you subtract them or add them, nothing's going to go away until you do something else. Well, I'll tell you, and then we'll do it, and I'll let you make a few notes on what we did here. Okay? If I multiply this equation by 3, will that change its solutions?
Oh yeah.
It won't change the solutions because I'm multiplying everything here by 3 and everything here by 3. Right?
Yeah.
And then what could I multiply this one by to make the x's go away? Well, if I multiply this one by 3, what am I going to have in front of x?
You're gonna have 9x. Or I mean 6x.
Well, if I multiply this one by 3, I'll have 9x, but I have 6x,
Yeah,
right?
yeah, that's on that.
And of course, I'll have 21y, and I'll have 48, right? So I'll have all that, but at least I'll have a 6 in front of x, right? Now, what can I do to this equation to get a 6 in front of x?
Multiply by 2.
Yeah. And what if I wanted a negative 6 in front of x?
Multiply by -2.
Yeah. So if I multiply this by 3 and this by 2, and then add the two equations, I'm going to have just an equation with y. And I can solve for y and then plug that back into one equation and solve for x, right? Okay? And once I've done that, once I've changed the equation like that, they'll be just like these. One of the variables will just go away when we add the equations. Okay? So that's where we're going. But I'm going to stop here for a minute and let you make yourself a few notes. And then I'm going to ask you to solve that system.